Okay, so chapter 3 is just graphing linear functions. And I'm going to do 3.1, 3.2, 3.3, 3.4, and 3.5 is what you're going to be doing. And I'm not going to do 3.6 and 3.7. So I'm going to just do 1 through 5 in this one. So 3.1 is about functions, is what it is. So what I want you to learn today is I want you to be able to tell whether the relations are functions and find the domain and range of a function and identify independent and dependent variables. So those are the three big ideas that I want you to understand today. So the first idea was just understanding the difference between a relation and a function. So this is where you might want to take notes. So a relation is just a pair of inputs and outputs. So I could say I have 2, 6. So my input is 2, my output is 6. I could say I have 3, 8. Input 3, output 8. I could then say I have another input of 2, 10. And then I have 5, 20. So this is a relation, is what this is. So this is just a relation. It's an input, output. So this is a relation. So a function, what a function is, it's when a relation that has an input, each input has exactly one output. So I could say 2, 4. I could say 3, 6. I could say 4, 8. And then I could even go a -2, 4, a -3, 6. So each individual input has exactly one output. So you can see here they have the same output, but that's okay. So you cannot have an input with two different outputs, and that's what I have up here. I have 2 with an output of 6. I have 2 with an output of 10. So this one is not a function up here. So this one is not a function because the relation has, the input has 2 different outputs. So in order to be a function, and so down here, these are functions, I know that each input has exactly one output. All right, so each input has exactly one output. So that's what makes it a function. And we're going to look at this a little more. Okay, so I'm going to teach these two words. They are in the next section as well. Okay, so a relation and a function, I kind of already talked about it. I know that they are ordered pairs. A function, a relation is just an input-output. A function has an input has exactly one output. So the next word is domain and range that we're going to look at. So the domain is my x values. All right, so that's what my domain is, and it's always my input. The range is just my y values, and it's always the output. So the next idea that I told you we're going to talk about is independent and dependent variables. So just to kind of give you a simple definition of it. So the independent variable can stand by itself. So let's say I have gas in the car. So I know my independent variable is I have gas in the car. So my dependent variable is going to be the miles I travel in my car. So I know how many miles I travel depends on how much gas I have in my car. Because if I don't have any gas in my car, I'm not going to travel anywhere. So those are independent and dependent variables. Okay, so the next thing I want to just talk about, and I know that you have been exposed to this before, is ordered pairs. So I know that I have an ordered pair is just 2 points on the coordinate grid. And I'm just going to draw a coordinate grid here and kind of talk about it. So when you're drawing a coordinate grid, you always need to put these arrowheads. If you're drawing a line on a coordinate grid, you need to put the arrowheads. If you're drawing a number line, you need to put the arrowheads, because if you don't, it just means that it stops. Okay, so the first thing that we're going to look at is the quadrants. So I know the quadrant. So this here is quadrant 1. So this is quadrant 1, and I know the points in this quadrant are always positive, positive. So if I have a point, let's say here, so this is 2. So this point right here is 2, 2. And I'm going to call this just point A. So I name a point with an uppercase letter. I know quadrant 1, my points are positive, positive. Quadrant 2, and I'm just going to use the Q. Quadrant 2, and we always use Roman numerals. So quadrant 2, the points are the X is negative and the Y is positive. So therefore, if I have my point 3, let's say 3, 4. So I'm going to call this one B. And this point here, I know is a negative 3, 4. So B point is 3, 4. So negative 3, 4. The X value is negative, the Y value is positive. My last one, or not my last one, my third one is quadrant 3. So I can say that this point here, I'm going to call it C, and the points in this one are always negative, negative. So this here I know is a negative 4. This one. Okay, so a negative 4, 1, negative 1. So that's the points, and they're negative, negative. And my last one here is quadrant 4. And so the points in quadrant 4, the X is positive and the Y is negative. So therefore, if I go here, I'm going to just call this D. And so I know that my points here are positive. So I'm going to say 3, negative 2. Okay, so that's the coordinate plane. And so when I have the coordinate plane, I know that I have an X and a Y axis. Another thing that's important is this point right here. This is the origin, so where it's 0, 0. Again, this is the Y axis. So here, I'm sorry, this is the x-axis, and this here is the y-axis. All right, next thing I want to talk about is mapping. So mapping is just saying kind of what I did on the first page is I said I have 2 and the output is 4. So here I have an input output. So on my first one I have 10 and the output is 15. And this one it says I have 20 but the output is 45. So it's not right across from it. And then on this one, I have 30. The output is 25. In this one here, I have 40. My input and the output is 35. So that's mapping. So here's mapping with domain and range. Remember I said my domain is my X values. And it's also my input. My range is my Y values. And it's also my output. So A goes to 1, B goes to 2, C goes to 3, and then D just goes to 4. So this is just mapping. All right, 2 more vocabularies, and then we're just going to go into the lesson. Okay, so these 2 vocabulary words, I'm going to be using them in the lesson. So I want to just make sure that you understand what they mean. So the first one is a continuous graph. So I'm going to go ahead and draw a coordinate grid. And I'm going to put my arrowheads. I'm going to say this is X axis. This is my Y axis. So this one here is going to be my continuous graph. So I know that when I have a graph, I have points on this graph. So I'm just drawing points to make my graph. So a continuous graph, what it says is it's connected together. So when I have a continuous graph, let me just make that an arrowhead just to show that it's going to go on and on and on. So a continuous graph is when you have all the points connected together with a line. So that means the values even between the points here, all these values between the points, those are solutions as well. So these are all, everything on this line, even though there's not a point there, it's still a solution. So it's still a solution, and it goes on. There's even more. It goes on. There's even more. So a discrete graph, so what it says is I'm just drawing it. Okay, so, and this is my x-axis. This is my y-axis. Okay, so what a discrete graph says, if I have a point, I have a point, I have a point, I have a point. So they're not connected. These points are not connected. So they're just individual points, and we keep them as individual points. So for example, I go to the store and I have $1 and I want to buy a cupcake. So I go to the store, I buy one cupcake, and I spend $1. I go to the store, I have $2, and I buy 2 cupcakes. So I can't buy half a cupcake. So that's why you do not connect these with a line. So say I can go to the store, I have $3, I can buy 3 cupcakes. I go to the store, I have $5, I can buy 5 cupcakes. You do not use, you don't buy half a cupcake, hopefully not. So it only ends up with whole numbers. So this is why this is called a discrete graph. You do not add the line. Okay, so let's go ahead and move forward. All right, so just going back to whether it's a function or just a relation. So remember I said every input has exactly one output for it to be a function. So that's what we need to look at is the inputs. So if I come over here and look at my input, oh, I have a 2. Input -1, I have a 2. Input 0, I have a 2. Input 1, I have a 0. And input 2, I have a 0. So none of my inputs repeat. So every input has exactly one output. So I would say this is a function. I can see that it's a function. And so I would write, because it says explain, so I would say every input has exactly one output. So that's how I would explain it. Every input has exactly one output. And again, this is in your textbook. So if you have it open, so this is on page 104, right? So now let's look at B. Okay. So again, I'm going to look at the input. 4, I have a 0. 8, I have a 7. 6, I have a 4. Oh, look here. I have another 4. So I have 2 4s here with 2 different outputs. This 4 has a 0 output, and this 4 has a 3 output. So therefore, this one is not a function. This one is not a function. And so how I would explain it, I would say the input, and this is how I would explain it right here. The input 4, so I'm telling you which one it is, has 2 outputs, 0 and 3. So this is why it's not a function. Okay, so let's look at the next one. So again, we look at our inputs. I have a 3, -1, 0, and 0. So once again, I have a 0 and a 0, and they have different outputs. So I would say this one is not a function. So this one's not a function. And again, here's the reason. The input 0 has 2 outputs, 5 and 6. All right, so here's the last one now. So I have -1 has an output of 4, and this is a mapping now. Do you see the mapping? A 3 has an output of 15, and an 11 has an output of 15. So this one here is a function. And the reason for it is every input has exactly one output. All right, so this one is a function. Okay, so we're going to do the progress monitoring. So go ahead and I'm going to put it up here. So I want you to do these 4 questions, and then I'm going to go over it with you. All right, so you try them. So you're checking your understanding of this concept. So that's why it's important for you to try them. And then I will go over the answers.